يدوي شغال يا خالد.
بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. I am Khaled Hajjaj العسيري. I am from King Abdulaziz University. Today, inshallah, I will present for Vermiola Louisiana basin exploration of hydrocarbon potential. These are my outlines of this presentation. Study area, geological settings, seismic interpretation, formation evaluation, fishes analysis, seismic well integrant, petroleum system analysis, and prospect evaluation, conclusion, and finally recommendation. I start as study area. I get this picture from Google Earth. It's for all Gulf of Mexico, and in a black box, that's my study area. The Gulf of Mexico is a circular basin shape which contains biosedimentary rocks. The age is between Triassic and Holocene, and it's surrounded from the north by United States and from the south Mexico. Continental shelf is less than 180 meters, and continental slope 180 meters to 3,000 meters. That's my data set. It's with 3D seismic survey and 12 wells. One of the wells is out the seismic data, and it's with the limited digital logs. Geological settings. In this slide, we will show how to separate between North and South America plates. The age of these plates start from Triassic to Miocene. So the separators will be start from Triassic to Miocene. In late Triassic rifting start between North America and South America plates. Gulf of Mexico structure and stratigraphy controlled by two main factors: fault blocks basin and salt dome. Fault blocks basin is formed by extension and listric normal faults. The Louisiana basin. Louisiana basin contained 9 subbasins, and our subbasin which we studied, Tesh and Vermiola. It's surrounded by east by Artifiela, and by the west surrounded by Merimento. This is the subbasin we will study, and it's contained by 243 acres. And this is the stratigraphic charts. And in the top, that's our reservoir. It will be in Miocene, and in the bottom, this is the well logs. It's source rocks. It's in Paleocene. Seismic interpretation. We're using the Petrel software to do the interpretation, and we use the seismic fishes techniques. We defined the seismic for 2 big units, the top and bottom, and we use the fishes analysis for each unit. This is the top units, and this is the lower. We defined 4 main normal district faults with rollover and 2 anticlines, between of them 1 syncline. And we defined one unconformity. It's between Miocene and Paleocene, and we defined it by truncanations. Fault interpretations. We used the fault interpretations module by Petrel also, and we defined 4 major faults. The directions northeast to southwest, and we have 2 many minor faults. It's for the same orientations. For attribute, we use the coherence attribute, and we figure out this figure. Here we found buried fluvial and point part. Point part for meandering rivers. Formation evaluation. This is my location maps, and we trace two intersection, A to A dash, B to B dash. It's through on my wells. This is the cross section one. We defined it by Petrel also, stratigraphic modeling. We flattened all the wells by seismic horizon one, and we will see the changes and how the lithology changes also. We do the same from B to B dash, and this is the wells, and this is the changes also. Because we have just the SB logs, with that we define the shale and non-shale. Fishes analysis. For fishes analysis, we use the stakes better to define the environment by SP logs also. And we defined three main environments: buried fluvial and delta system, and fluvial point part. As we see A to A dash, we found here the delta, and here we found here the fluvial main. We found buried fluvial here, and the delta on this side. Seismic well integration. We display here the seismic section with the logs, and with another standard logs. We get it from another paper. We try to convert our interpretation with the standard interpretation. That's in line, and we do it also for X line. And this is the static table for sand and shale ratio. We have two big units, as we say, Miocene and Paleocene. The Miocene, we found this, it's more sandy from sand ratio, and the Paleocene is more shaly. Because that we defined the Miocene is good reservoir. Petroleum system analysis and prospective evaluation. As we say, the Miocene is a good reservoir, because that we found here the sand package to be a good reservoir. For the last year, we found we lose the signal because it's salt, as we say in the start. And we use also the resistivity logs, and it's indicator to lower Miocene reservoir. As a conclusion, our source rock is Wilcox reservoir is lower Miocene sandstone. The shale rocks is multi-layered between the shale and sand. The trap, we have a structure fault trap. Where we should search, we chose 4 leads. This is the 3, and it's showing in line, and the 4th one it's in X line. We should calculate the prospect chance. If it's good prospect chance, if it's come close than 1, it's good chance. But if it's low, the risk is high, and we cannot. And it's. For late one, we have anticline and structure trap, and is the best lead we should search hydrocarbon for, and the risk factor is low, it's 0.4. Lead 2 also we have the anticline, and we have structure and the closure. the risk factor it's become 0.5 after we calculate this thing. Lead 3, it's if you remember the picture, is in upper here. We didn't have structure, just one pole, but it's maybe reservoir for the migration. The oil is become migration. And here we use another type of attribute. It's called amplitude. We use it because we didn't have too much structure to be clear. With that we use this. We use this attribute. And risk factors become 0.6. For lead 4, it's the same for lead 1 and 2. The risk factor is 0.5, and we have closure and structure trap with faults. Conclusion: oil and gas generation. We have one play in tertiary, 4 leads with 3 prospects, 3 places we are sure about it. So invest in the Louisiana basin. Final recommendation, because we didn't have full data, full logs data as a gamma ray resistivity, density and neutron and sonic. And we lost also the core data, we lost the check shocks data, geochemical analysis and velocity data. If we did these things, we can calculate the volume calculation. Question?
First of all, let me tell you that Khaled quite honestly